Hi everyone and welcome to today's problem where we'll be solving minimum size subarray sum. You're given an array of positive integer nums and you're given a target. You're supposed to return the minimal length of a subarray whose sum is greater than equal to the given target. If there exists no such subarray, return a 0 instead. Now we have example 1 where the target is given to be 7 and nums has 2, 3, 1, 2, 4, 3. And why is the output 2? Because the smallest subarray that you can find whose sum is greater than equal to target is nothing but this subarray of 2 elements having the elements 4 and 3. Now you might also say that, hey, isn't this subarray also having the sum greater than equal to 7 because the sum of this 3 length subarray is 9? You would be right. There can be many such subarrays where the sum is greater than equal to target, but we are concerned only with finding the minimum subarray, as in the minimum length subarray. So even though there might be many subarrays whose sum is greater than equal to target, we want the minimum, and in this case the minimum is having 2 elements, the minimum length subarray. Similarly, for example 2, they have target equal to 4 and nums as 1, 4, 4. In this case, you can even look at the single length subarray, a subarray consisting of a single element whose sum is greater than equal to target, and so the answer is 1. You cannot do better than one element, right? A subarray has to have at least one element, so this is the minimum, of course. In example 3, you have target as 11 and you have nums as just all ones. In this case, you cannot even find a subarray whose sum is greater than equal to target, so the output is 0. So this is the problem. Let's try to understand how are we solving this using sliding windows. Remember, target is greater than equal to 7 and you need minimum subarray size where subarray sum is greater than equal to the target, as I've written here. Now if we try to understand this problem, we have two pointers. We have an I pointer and we have a j pointer, and initially the I pointer starts at 0 and the j pointer also starts at 0. So right now we're looking at the one length subarray, that is a subarray consisting of only a single element, that is this value 2. So if you want the sum of this subarray you're looking at, isn't the sum nothing but 2? 0 plus 2 equal to 2. Is this a valid subarray or not? No, this is not a valid subarray. Why? Because for a subarray to be valid, its sum has to be greater than equal to the target. In this case, the target is 7, but the current subarray sum is 2. Because the sum is lesser than the target, you need to proceed or you need to expand and add more elements into your subarray so that the sum becomes greater than equal to target, so that the current subarray becomes valid. So what does expand basically mean? Expand means move your j pointer. So if you look at the next slide, our j pointer moved from index 0 to index 1 and we've added one more element into our current subarray. So now the sum is nothing but sum equal to sum plus nums of j. Sum was already 2 corresponding to this element, and now the sum is 2 plus 3, that is equal to 5. Now we are looking at the 2 length subarray, that is a subarray of size 2 consisting of the elements at index 0 and index 1, that is the values 2 and 3 respectively. Remember, I is still fixed at 0. The j pointer is the one that's moving. Now the same question I asked you, is this subarray valid? No, this subarray is also not valid because the sum right now what we have of this subarray is 5, which is less than the target. Remember, we want to find the subarray whose sum is greater than equal to the target as per the question. Since the sum here is lesser than target, we have to proceed. Now proceed or expand. Expand means move your j pointer, try to add another element. If we go to the next slide, we move the j pointer forward and our j pointer now reaches index 2. When our j pointer reaches index 2, we have sum equal to sum plus nums of j, and you already had the sum as 5 and now the sum is nothing but 6. Now if you look at it again, is this a valid subarray or not? No, this subarray is not valid because the current subarray sum is 6, but you're looking for a subarray sum greater than equal to target, which is 7. So right now, since sum is less than target, we proceed. Proceeding means expanding. Now again your j is at index 3. Remember, this is index 3 here. So basically your I is fixed at index 0 and your j came to index 3. The green pointer, this green pointer is what is j currently pointing to. Now when you do sum of these first 4 elements, that is subarray you're currently looking at, you get 6 plus 2, that is 8. Now why? Because you already had 6 as the sum and then you just add the jth element, that is element 2, to the sum, and you get 6 plus 2, that is equal to 8. For the first time ever, now we have our current subarray sum greater than equal to target. So this means that the current subarray that you are looking at is a potential answer. Now, because this can be a potential answer, we have to update our answer. We have a variable called answer that is set to infinity. Okay, and now we're going to check between my answer infinity and my current subarray size, which is smaller. Of course, the current subarray size is smaller than infinity, so the answer is updated to store the current subarray size, which is 4. Now you might ask, how did I get the current subarray size as 4? It is nothing but j minus I plus 1. I is pointing to 0, j is pointing to 3. 3 minus 0 plus 1 is nothing but 4, indicating that the subarray I'm looking at currently has 4 elements. So this is how this happens. Remember, this is the first case where our sum was greater than or equal to target, and so we found a potential answer and we updated our answer variable. The second important observation is, whenever this condition is met, listen, now you have the first 4 elements, right? The first 4 elements that constitute a potential answer. You are looking for a minimum subarray. So here you're going to shrink your subarray. Now the question is, how do you shrink your subarray? You shrink your subarray by moving your I pointer. Now the j pointer remains the same. The j pointer fixed there, but our I pointer moved forward. I pointer was fixed at index 0 and we moved I pointer from index 0 till index 1. Now our subarray that you're looking at was index 0, index 1, index 2, index 3. Now you're just looking at index 1, index 2, index 3. What happened? You ejected that index 0, as in you're trying, because you found a valid subarray of 4 elements, you're trying to eject elements from the left side in order to see whether the subarray you are ending up with, is it still a valid subarray or not, because your goal is to minimize the subarray size. So right now I moved forward, and like I mentioned, the subarray changed from 0, 3 to 1, 3. So because I've ejected out the element at index 0, so shouldn't I update my sum? My sum was 8, and now I've ejected the element at index 0. So now the sum that I have is nothing but 8 minus 2, that is equal to 6, denoting the sum of these 3 elements, 3 plus 1 plus 2, if you want to verify, is nothing but 6. So this is the subarray I'm looking at here. But is this a valid subarray? No, this is not a valid subarray, because the sum I'm ending up with is 6, and the sum that I want for a subarray to be valid has to be greater than or equal to target, which is 7. Now, I've also added a note here which says keep shrinking the I pointer as long as your sum is greater than or equal to the target, because all those are valid subarray candidates. Stop as soon as sum becomes less than target. In this case, of course, our sum immediately became less than target, so we don't do any more shrinking. But I have added this note and I want you to think about it. See, let's say we have a valid, subarray candidate, right? And then you updated your answer. Why do we try to shrink our subarray? Because in this case, you want to find out a minimum subarray candidate. You already have 4 elements. Let me remove the leftmost element and try to see whether the remaining subarray still meets the condition. So I'll get another valid subarray candidate. That is kind of the intuition of it. Right now, of course, our sum was 6, and now 6 is less than the target. So what do? You try to add more elements in order to meet your condition or criteria of having a valid subarray. So you move forward and your j, now you expand your j. If you look at the previous slide, as soon as your sum became less than target, you again go back to your normal kind of work of expanding the j pointer, trying to add more elements to satisfy the sum greater than or equal to target. So j went to index 4 and sum is nothing but 6 plus 4, that is equal to 10. If you look at this right now, our sum is greater than or equal to the target here, because the sum is 10 and the target is 7. Because the sum is greater than or equal to the target, this is a valid subarray. I equal to 1. From I equal to 1 till j equal to 4, you're looking at 4 elements, 3, 1, 2, 4. This is a valid subarray candidate, so you have to update your answer. Now you're going to check. The answer already has the value 4, and the current subarray size that you're looking at is j minus I plus 1, which is nothing but 4 minus 1 plus 1, that is 4. Now the answer does not get updated, it remains at 4. Now I've also added one more note stating that, remember, the j pointer always moves when the sum is lesser than the target, looking to increase the sum so that it becomes greater than or equal to target, like I've repeated a couple of times earlier. Now, since I found, sum greater than or equal to target right now, what will I do? I will try to shrink. I will try to shrink and see if the remaining subarray still remains valid. So again, my I moved forward and I moved my subarray from index I equal to 1 to I equal to 2. So now my index I equal to 2. I just removed the I equal to 1 element. Since I've removed the I equal to 1 element, should I not update my sum? Yes, I should update my sum. My sum was 10 before, and now the sum that I have is nothing but 10 minus 3, that is 7. Why is it 7? Because I'm looking at the subarray 1, 2, 4 now. Now, here, The sum is 7. Is this a valid subarray candidate? Yes. This is also a valid subarray candidate. Remember, 3, 1, 2, 4 was a valid subarray candidate. You tried to eject the element at index 1. After ejecting the element at index 1, the remaining sum that you have is still a valid subarray candidate. So you have to update your answer again here. Now the answer is nothing but min of answer comma j minus I plus 1. Answer already had 4, and now the current subarray size is nothing but j minus I plus 1, which ends up to be 3 because you're looking at only 3 elements, 1, 2, 4, and now the answer gets updated to 3. That's why I added that note earlier stating that keep shrinking or keep moving the I pointer as long as your sum is greater than equal to target, because you want a minimum subarray. So moving forward, still you found, right, 7 it is. So still this is greater than equal to target. So again you have to shrink. So again here I try to move my I pointer, and my I pointer is now at index 3. Now because I have just ejected the element at index 2, I have to update my sum, because right now I'm only looking at this 2 element subarray. So how do I update my sum? My sum was 7 before because I wanted to look at 1, 2, 4. I removed 1. So right now my sum is 7 minus 1, that is 6. Just the elements from the, the pointers that I've mentioned here, from the red pointer to the green pointer, or from the I to the J. This is I pointer and this is the J pointer. Green denoted by J pointer. So right now the sum is lesser than the target, so we have to expand J. So now our J moved forward and J reached 5. Now if you look at it, sum equal to sum plus nums of J, and J is 5. So now the sum became 9. Now since the sum became 9, is this a valid candidate? Yes. Because this is a valid candidate, again I update my answer, and now my answer remains 3. Because again I'm looking at these 3 elements here. Moving forward, now what do? I try to shrink. Because my sum is greater than equal to target, I try to shrink and see if the remaining subarray is still valid. So how to shrink? Just move your I pointer forward. Now my I pointer came forward to index 4, and now since I've just ejected this element here, I have to update my sum, and sum equal to sum minus nums of I. Before moving the I pointer forward, you have that I pointer, so you can just do sum equal to sum minus nums of I, and then so when you do that, you basically get 9 minus 2, that is equal to 7. Now the reason why I cut this is because you're moving your I pointer forward, but I make it clear, before you move the I pointer forward, just subtract it, because after you move the I pointer forward, your I is going to point at index like 4, right? But you want to remove the element at index 3. So just it's an implementation detail that we can look at later, but all we have to know is, in the previous slide we looked at 2, 4, 3, the elements 2, 4, 3. In this current slide we're looking at the elements 4, 3. You have ejected the element 2, so updated the sum to be 7. In this case, after ejecting the element 2, still the subarray that you're looking at is valid because the sum is greater than equal to target. Now updating the answer, and your answer became 2. How did the answer become 2? Because now you're looking at these 2 elements and this is a valid subarray, so now our answer became 2. Now, since 7 was greater than equal to target, you again try to shrink. So there are just 2 main things here. If your sum is greater than equal to target, try shrinking. If your sum is less than target, try expanding. Expanding means moving J pointer forward, and shrinking means moving I pointer forward. Now going back, now you have shrunk by moving the I pointer forward, and our I is at 5. Now since you're looking at 4, 3 in the earlier slide, you're trying to remove this element 4 because you're just looking at one element 3 here. So sum becomes sum equal to sum minus nums of 4, and 7 minus 4. This is nothing but 3. This is the current subarray sum you're looking at, just this element alone. Because you're looking at just this element alone, and this element is less than target, you have to try expanding the J. So J means G pointer moves forward, and now I've exhausted the array, and the answer what you have, that is the final answer. So let's try to code this out and see, whether we get the correct answer or not. I'll use C++ here, but feel free to use any sort of programming language. So first I will take the size of size of my array, right? Now I have 2 pointers, I and J. This is kind of a template that you will follow for almost all the 2-pointer problems, or sliding window problems to be more exact. So I have I equal to 0, J equal to 0, because if you looked at my first slide, I and J, the green and the red pointers, both pointed to index 0. And now, what is my stopping condition? If you looked at the PPT, right, if I just quickly switch over here, my stopping condition was when this green pointer reached the end. Green is J. So as long as my J pointer is less than size, I can do my whatever, I want to do inside. So as soon as my J pointer reached the end, I have to stop the iterations. Now what do I have to do inside? Here's what I want you to think about. So let me have another variable called sum, because sum is also really important. Right, so I have the sum. Now I'm going to do sum equal to sum plus nums of J. if you look at the slide, it's very simple. If you look at the first slide as well, right, what exactly happened if you remember here? In step 1, if you look at it, the starting slide ever, all you had to do was you had to add, always you were adding this to the sum the element at index j. That's what you were doing from the starting. So right now, even the next slide, whenever you're expanding j, right, you're just adding the element at index j to the existing sum. If you look at it, that's what was happening. So that's what we're doing here. So sum plus equal to nums of j. Now, what is kind of the criteria where I have to shrink? Remember, when did we shrink? We shrunk always when the sum was greater than equal to target. So I have a simple line, while sum is greater than equal to the target given, I have to do some shrinking. So this is what I need to think about. What do I do and how do I shrink? It's very simple. As I discussed, shrinking just means moving the I pointer forward. But in this process of moving the I pointer forward, is it possible that I go into some out of bounds condition? Of course. So just to handle that, I'm going to say while I less than size and the sum less than greater than equal to target. Keep shrinking. Now, when I'm moving the I pointer forward, it means that the previous I pointer element I'm ejecting. So how do I do that? I do sum equal to sum minus nums of I. That's all I'm doing. Very simple. Because I'm moving my I pointer forward, I'm going to lose or eject an element. That element has to be removed from my sum. So what essentially happened right now? When I come outside this while loop, I am guaranteed that this condition fails. If this condition fails, it means that when I come outside the while loop, I am guaranteed that my sum is going to be less than the target. So in the next iteration, I'm going to go to the next j. So I'll write j plus equal to 1. In the next iteration, I'll go to the next j index and I will try to expand. Because I expand only when my sum is less than target. I shrink only when my sum is greater than equal to target. So here is the code. But I have to update my answer as well. That is one part that's missing. So let's say that my answer is set to some big value like int max, right? Where to update the answer? What is a valid subarray? A valid subarray is a subarray whose sum is greater than equal to target. So where is that? Every iteration of this while loop is considering a valid subarray. Why? Because this while loop will come inside only if the sum is greater than equal to target. So every iteration of a while loop is processing a valid subarray. So right now I will simply say, you know what, my answer is nothing but min of answer comma j minus I plus 1. So here's what I'm doing here. Because every iteration of the while loop is processing a valid subarray, I'm computing the minimum between what I've answer already had stored and the current subarray size. The current subarray size is nothing but j minus I plus 1 because you're currently looking at the subarray from index I to index j. That's all it is. Right now, I'm going to add a condition stating that, you know what? It says in the question, right? If there is no such subarray, return 0. So that's what we have to handle. We will check. If our answer never got updated and still remained int max after all the while loop that we're doing, we are just going to say, hey, return 0. Otherwise, it's totally fine for us to return our answer. Think about the time complexity here. Some people get confused and say n square, but this is not n square because your I and j are not dependent on each other. I is going to run through all the elements, j is going to run through all the elements. So this is more of a linear time complexity. So let me run this and see if this is correct or fix it. So we get accepted here, and yeah, all the best.